Hello, my name is Jade Leonard. This is the week 15 solving a combined spectral problem for Organic Chemistry 1 at the University of New England. So I have group 10, letter J, and my compound was C10H12O. So let me just move that over. So first, I analyzed the IR spectrum of it. You can see here, right about like 3,000. It's a little bit over, so like 3,050 is an sp2ch. This next one is about 2,950 range. That one's sp3ch, I found it to be. This really strong peak here, that one's about like 1,700. That's I found to be sp2c double bond O. And then this peak here is an sp2c double bond C. That one's about like 1,550. And then this last peak here I found to be a CO bond. And this peak right there, the sp3, that one's at about like 1,250. So I'm getting my numbers from, I have my charts down here that I'll go through. But next, we're looking at the, this 13C NMR spectrum. Up first, about like 29 ppm is a methyl group. And that's going to correspond to bonds 1 and 4 on my final picture that I found it to be. Next, I found a CH2 group. That would correspond to bond 3. And that one's about like 45 ppm. Up next, right here at 125 ppm, I found an aromatic C. And that's going to show bond 8. And there's another aromatic C for bond 6 and 7. That one's right about 128 ppm. Next, I have another aromatic C at 140 ppm for bond 5. And then a C double bond O at 207 for bond 2. And on the 1H NMR, first I have a singlet at 3H, this tall peak here, and that's about 210 ppm. Then the 4H is a sextet, and that's 275 to 280, in that range, ppm. And then 735 to 7.45 ppm, a multiplet, 5H. Then we'll go into my my charts. So first I found the degrees of unsaturation. That would be using this equation here. 2 plus 2 times the number of carbon atoms minus the number of hydrogen atoms plus the number of nitrogen atoms, all divided by 2. I have 10 carbon, 12 hydrogen, no nitrogen. Divide that by 2, I got 5. So 5 degrees of unsaturation. The molecular formula, again, is C10H12O. So analyzing the IR frequency, I have the frequencies listed here. And then the functional groups, the sp2ch bond at 3,050 centimeters to the -1 is going to be an aromatic CH group. The sp3ch at that frequency range I found to be a methyl CH3. The sp2c double bond O is a carbonyl ketone, and that's around that frequency of 1715. The sp2c double bond C is an aromatic bond, and then sp3co I found to be a CO bond. So then looking at the 13C, we have the methyl at 29, a CH2 at 45, an aromatic C at 125, aromatic C at 128, and another one at 140. And finally I have a C double bond O at 207 ppm. Looking at the 1H, chemical shift of 2.10, has an integration of 3H. It's a singlet, and I interpret it as a methyl. That is an N. I found this by using N+1. 2.75 to 280 ppm has an integration of 4H. That's a sextet, and that is CH2. 7.35 to 7.45 ppm has an integration of 5H. Found that to be a multiplet, and that is an aromatic H. So the proposed structure that I found this to be is right here. The longest chain has 8 carbon. There's a double bond O, and then those are just the numbered carbons that I matched up everything with. So 1, 2, 3, 4, 5, 6, 7, 8. So that was the structure I found this to be based off of that information from the NMR spectra. So thank you for watching.